All right, we're moving on to chapter 6. I kind of think of this chapter as a cleanup chapter. It's got like a bunch of sections that are random sections that kind of pull things together. They are interesting sections. So this first section is a continuation of the triangle proof stuff that we've been doing. And so the first part of this is what we call a detour proof. And so the way a detour proof works is as such. It starts out with, you're given here in this example, circle O, and you can see that from circle O, you're missing some radii, so you might want to draw the radii in there. And it's given that angle B is congruent to angle C, which so if angles and sides, you know these are congruent. And you're trying to prove that AO bisects BC. So what you need to do really, I take a step back from that, I need to prove that this is congruent to this. So you can see that maybe, the two triangles I need to prove are these two. And so I go, well, hey, I got a flexive property down the middle. So that gives me 3 parts of the triangle, so I'm in good shape. I can prove those two triangles congruent. And then I go, oh no, I got the bad word, side, angle. So I can't use those two triangles and prove those two triangles are congruent to each other because it's a bad word. So I am forced to do what's called taking a detour, okay? And so I need to prove a different set of triangles congruent first, and then go back and try to get those triangles congruent. So you're going to end up proving multiple sets of triangles here. So if I look at this thing here, I'm going to end up with these radii congruent, and you got a reflexive all the way down the middle, like right here, all the way through here. And so by side, I know that the big triangles, so these big triangles are congruent to each other. And then by CPCTC, I can see that I can get these two angles up here congruent to each other. And then I can finish the proof by proving the original set of triangles that I wanted to prove congruent. Okay, so here's what the detour proof looks like. Let's write this out. So like I said, we need to have radii congruent here. Let's draw in the radii, so let's draw BO is congruent, draw BO and OC. And I can say that BO is congruent to OC because radii are congruent. And then I can say that by reflexive property, I know that AO is congruent to itself. Because remember, we're trying to prove the big triangle is congruent. And I know that AB is congruent to AC because of if angles, then sides. And then the triangles are congruent by SSS. Steps 5, 3, and 4. And now I can say that those upper angles are congruent. So angle BAO is congruent to angle CAO by CPCTC. And now I can prove the original set of triangles that I was thinking of proving congruent. Those two, the yellow ones. Okay, and it's going to be because I have angle, side, angle here. So it's going to be angle, side, angle. So the first angle comes from step 1, the angle B congruent to angle C. sides come from if angles and sides, so step 5. And then we have a CP/CTC from step 7. From there, I can now go to CP/CTC and say that BE is congruent to CE. And then I can say that AO bisects that because if I have two congruent segments, and it's a segment bisector. Okay, so that's the first concept. That's called the detour proof. Second concept in this section is this concept. Okay, so if I have two angles that are both supplementary, so something like this, supplementary, these are next to each other, supplementary, and they're congruent to each other. Well, if they're both supplementary, then they have to add up to 180. And if they're congruent to each other, you know that both of them have to be 90. So that means you end up with a right angle here and a right angle here. This is what we call the right angle theorem, or shortcut, RAT. Now I'll let you go ahead and write RAT. So the condition is, if angles are supplementary and congruent, so those are the two conditions you need, then you know that they are right angles. And that's because of RAT. Okay, so let's try a proof here. The first proof we have here for RAT is that XR is a bisector of this angle up top here. So this angle is congruent to this. Angle Y is given to be congruent to angle Z. So I got two sets of angles congruent there. And I know I got a reflexive down here. So by angle and side, I know that these two triangles are congruent to each other. And then by CP/CTC, I can get that this angle is congruent to this angle. And we know that they're supplementary because if they're straight angles, then they're supplementary. And then you can say that they're right angles. And then from there, you can say that it's altitude. So let's go ahead and let's write this out. So step 1, bisector. Step 2, you know that angle YXR and angle Z XR are congruent to each other. If you have an angle bisector, then you have two congruent angles. Step 3, let's say that angle Y is congruent to angle Z. It's given. From there, I could have, by the way, I could have also said that these are congruent to each other instead of using the reflexive. Let's do that just for laughs and giggles here. XY is congruent to XZ. If angles and sides. Now I can say that angle or triangle YXR is congruent to triangle ZXR. By angle side angle from steps 2 through 4. Next, I can say that they're supplementary, so angles are congruent first. So XRY is congruent to angle XRZ, CP/CTC. I can say that those angles are sup to each other. XRY is supplementary to angle XRZ, because if you have straight angles, then you have supplementary angles. And then in 8, because I have these two things, I have two angles that are congruent and supplementary, I know that those are right angles. So angle XRY and angle XRZ are right because of RAT. Now I can say that because of RAT, I can say that they're perpendicular. So XR is perpendicular to YZ. You have right angles, you have perpendicular lines. And now I can say it's an altitude. Okay. So those are the two concepts from this section. It's detour and RAT. Let's go to the backside and try a couple more proofs. Okay, we're on to the backside. We'll go over a couple of proofs here that have to do with detours and RATs. So I'm probably not going to write out these proofs in their entirety. You're probably at a point right now where I think we can just walk through some of these proofs. So PQ is the first thing that bisects YZ, so I know that this segment is congruent to this segment right there. Q is the midpoint, which makes this congruent to this. Angle Y is congruent to angle Z. WZ is congruent to YX. And I'm trying to prove that PQ is an altitude of the triangle. And so if I look at this thing, what I'm really looking to do here is I'm trying to prove that these two angles are congruent to each other. Because if I can prove they're congruent to each other, they're already supplementary. And I can prove that they're right angles and therefore altitude. The question is, can I prove that these triangles are congruent to each other? And then go by CPCTC. And the answer is, I don't have enough information. It looks like I have a reflexive right here, but I only have two parts of that. However, I can see, hopefully, that I do have enough information to prove these two triangles congruent to each other. Okay, so what I'm going to end up doing is proving triangle WZP congruent to triangle XYP by SAS, and then the information I can steal from that is, I can borrow from that is that WP is congruent to PX. I can get that these two sides are congruent to each other right there. Because if I do that, then I can go ahead and prove the two yellow triangles congruent to each other by SSS. So it's going to be triangle WPQ congruent to triangle XPQ by SSS. And then now I can say that these two bottom angles are congruent to each other. So angle PQW is congruent to angle PQX by CPCTC. And then I can do a RAT, and then I can go from there to an altitude. Okay, just like we did on problem number 2 on the front side. Okay, let's jump to the next one. Okay, so given that Fi is congruent to IL. I is the midpoint of OS, so that means that this is congruent to this. I also, hopefully you can see that I got vertical angles right there. XOF is congruent to ESL, which is right there. And I'm trying to prove that XO is congruent to SE. So there's a couple of ways I can approach this, but it looks to me like I can go ahead and prove the inside triangle is congruent first. So I can prove that these two triangles are congruent to each other first. Now, that's not going to get me to, it looks like the ones that I need are these two, right? If I got these two, then I can do a CP-CTC and get XO congruent to SE. So we'll have to work our way there. If I prove the yellow triangles, so let's write down, prove the yellow triangle is congruent. So triangle OFI congruent to triangle SLI by side angle side, then I definitely can get FO congruent to SL. That'll be helpful. That's a piece of the green triangles. So I can do this is congruent to this. So now I have angle and a side, and I just need one more piece to get the green triangles congruent. And from what it looks like I can do this. And this is a little bit tricky. Let me use a different color here. Let's go purple. It looks like I can go with this one congruent to this one by CP-CTC, and then say that these are supplementary to it. And if they're supplementary, then they're congruent. They're supplementary to congruent angles, they're congruent. So I can do that angle OFI congruent to angle SLI. That's also a CP-CTC. And now I can say that these two angles are supplementary. Oh no, I can say that. Sorry, angle OFI is supplementary to angle XFO, and angle SLI is supplementary to angle SLE. Now we know that these two are congruent, which are these two. So therefore, you can hopefully see that these two angles are congruent to each other because they're supplementary to congruent angles. And so that means that these two are congruent. So then I can say that triangle XFO is congruent to triangle ELS by angle side angle, and then CP-CTC it to get XO congruent to SE. Okay, hopefully you're okay with that. That is the idea here with Detour and RAT. Hopefully you'll have success as you go ahead and try some of the mountains on your own. All right, take care.